Hello and welcome to the section 10.5 lecture today. Today we're going to move a little bit from expressions into equations, and we're going to look at solving some polynomial equations by factoring one side and figuring out what the variables can be based on that. And there's an important property that I think this is an interesting one in one of my undergraduate classes. I had like a 3-page proof of this, and it was still not good enough time and time again. It was a very interesting one, and so to go back down and dig through all of the requirements of this was a hassle, to say the least. It's called the zero product property, and it says that if we have two real numbers, and if their product is zero, if when you multiply those two numbers together you get zero, the only way that's possible is if one of those two numbers is zero. So it's very interesting that this is the case because we typically accept the other direction. That if I have two numbers and one of them is zero, then when we multiply them, obviously the answer is zero. But it takes a lot more to say it the other direction. But it is a good thing that we can just use. And avoid that 3-page proof. So anyways, when we want to solve a polynomial, we want to get everything on one side, zero on the other side. And I typically like to put zero on the right side. And then I want to factor the left side, so what we just did yesterday, and then use the zero product property to solve it. Okay, so let's take a look at an example. So right now, I don't have zero on the right side. I need to get that. And I'm going to get that by subtracting 75 on both sides. I don't want to take away from all the room we have, so I'm just kind of doing it up in my think space a little bit. So I'm going to have 6a squared minus 15a minus 75 equals 0. Now, one thing I know is that all these are multiples of 3. So I'm going to go ahead and factor out a common factor of 3. And that's going to give me 2a squared minus 5a minus, wish I had that calculator handy. I don't know why I'm doing that. Okay, come on. Use your brain. I know it's early, but use it. Minus 25 is equal to 0. Now, this will be a little bit easier for us to factor using our Australian method from yesterday. All right, so I'm going to have 2a, and I want to think about two numbers that multiply to give me negative 50. I'm going to do that thinking over here. Multiplying to give me negative 50 and adding up to negative 5. It's probably going to be negative 10 and positive 5 because those add up to give me negative 5. Let's go and put them in there. Negative 10, positive 5, and that is going to be off by a factor of 2, so I will want to divide that by 2. The common factor of 2 comes out of this one to where I get 3. I'm going to say times 2 times a minus 5 times 2a plus 5. And I'll clean all this up in just a second. But all that's being divided by 2, and those 2's cancel out. And so that was just factoring with the Australian method. And what that gives me is 3 times a minus 5 times 2a plus 5. All that equals 0. Now, the zero product property is written for two numbers. It's really any combination of any number of numbers. If I have three numbers multiplied together and they equal 0, then one of those three, at least one of those three, had to be 0. Okay? And so here, using the zero product property on this one, tells me that either, I'm going to just write that, either 3 is equal to 0 a minus 5 is equal to 0, or 2a plus 5 is equal to 0. So there's some things that we can and can't do. I can't turn a 3 into a 0. So that's just becoming a non-factor. That one's going to be a 3 no matter what I do. On this one, I can add 5 to both sides. And that tells me that a could be 5. Or in this case, I would subtract 5. And I'd get 2a equals negative 5. And I'm going to divide by 2 to get negative 5 over 2. And it turns out from what I can deal with, from the a's that I can adjust, a either has to be 5 or a has to be negative 5 halves, negative 5 over 2. Those are the only things that I can control. I can't control numbers. They're stuck at whatever they are. But I can do this much at least. Okay. The next one that I have is already factored out, and this is just to reinforce that strategy of either this has to equal 0, this has to equal 0, or this has to equal 0. Again, I can't turn 4 into 0, but I can do something with x to make x plus 6 equal to 0, because if I subtract 6 from both sides, that would give me x is equal to negative 6. And I can even turn x plus 3 equal to 0 by having x equal negative 3. So those are my two options. Either x equals negative 6 or x equals negative 3 makes that work. Keep in mind that that doesn't work with any number on the right side. The reason we didn't say, well, that means like I could factor this side right here and say that it's 3a. And just factoring this, I'd get a, oh crap, not quite. I'd get 2a minus 5. I can't say that in order to make something equal 75 up here, that one of the numbers is 75 or another one of the numbers is 75. That's not the case. It only works with 0. That's why we want to put everything on the left side, 0 on the right, factor and solve. Okay. This one I already have everything on the left side and 0 on the right. So now I'll factor. I'm actually going to pull out a common factor of 3 first. It's going to make that x squared plus 10x. And 48 divided by 3. Ooh, yeah, that does work. Let me just figure it out real quick. We get 16. Okay, that's going to make life easier. Factoring out that common factor of 3 first. So I need two things that multiply to give me 16 and add up to give me 10. I think that's going to be 8 and 2. So we get x plus 8 and x plus 2. Kind of fast tracking the factoring step there, but go ahead and check it out and see if I'm right. So that either means that 3 equals 0, x plus 8 equals 0, or x plus 2 equals 0. There's nothing I can do with the 3, but I could change x to make one of these two things 0. X could either be negative 8 or negative 2. Either one of those values for x would make this whole thing equal to 0. Just to check, we can plug in 2 and check it out. Negative 2. Negative 2 squared is 4. 3 times 4 is 12. I'm going to make a note of that. 30 times negative 2 is negative 60. And 48. So 12 and 48 is 60. 60 minus 60 equals 0, so it works. Negative 8 would give you a similar result, but I don't want to calculate that much. For this one, I'm going to add the 38b to both sides and add 21 to both sides. So I get 5b squared plus 38b plus 21 is equal to 0. I don't have any common factors here, so I'm going to have to do the hard work. 5 times 21 is 105. So I want them to multiply to 105 and add up to 38. I'm thinking 7. I think that works. Let me just check. 105 divided by 7 is 15. No, that's not the case. Okay, let's do it the hard way then. 105 divided by 3, that would be the one. 105 is 3 times 35, and 3 plus 35 is 38. So I'm going to have 5b plus 35 times 5b plus 3, all that divided by 5, and I have a common factor of 5 in here. So, oops, I'm going to take that 5 out. Good job. And I get b plus 7, 5b plus 3, all that over 5. That 5 cancels there. So that equals 0, which means that either b plus 7 equals 0 or 5b plus 3 equals 0. B here would have to be negative 7. And here I'm going to subtract the 3. I'll go ahead and write it. There's kind of a quick way to do these, but I'm not the big fan of that memorization way. I do it because it's ingrained in my brain, but I don't necessarily like to teach those memorization techniques. So one of these two things has to be true. Either b has to be negative 7 or b has to be negative 3/5. The next one, I'll move the negative 2r over by adding it to both sides. So I have 3r squared plus 2r minus 1 equals 0. So now I need two things that multiply to give me 3 and add up to give me, multiply to give me negative 3 and add up to give me positive 2. For that to be a positive, I think it's going to be 3 and negative 1. 3 and negative 1. So we're going to have 3r plus 3 times 3r minus 1. And that's off by a factor of 3. The common factor of 3 is in this set of parentheses. So r plus 1 times 3r minus 1 divided by 3. Those 3's cancel, and that equals 0 by setting r plus 1 equal to 0, or 3r minus 1 equal to 0. This is going to be r equals negative 1, or add 1 to both sides and divide by 3. Okay, come on. I was going to say r equals 3. That's not quite it. 1/3. So I have r equals 1 or r equals 1/3. Let me actually redo that. Those are the two possible answers. Okay, you go ahead and try. Go ahead and pause the video and give all 4 of these a shot. Hopefully I had a chance to do that. Let's start with the easy ones, or the easy one. 3v plus 2, okay, come on, equals 0, or 5v minus 1 plus 1 equals 0. You should get v equals negative 2/3, or v equals negative 1/5. On this one, we do need to factor it. I need things that multiply to give me negative 30 and add up to, thinking too hard, add up to negative 7. Maybe negative 10 and positive 3. 5v minus 10. 5v minus 3. All that divided by 5 equals 0. I have a common factor of 5 in this one. V minus 2 and 5v minus 3. Divided by 5 cancels that out. So that equals 0. And we should get v equals 2 or v equals 3/5. To briefly talk about the quick way that I'm getting those, just in order to save time because we've done that a couple times already, it's always your variable. I don't want to write it out. I just want to talk about it. Kind of a quick method. It's always the opposite of kind of the y-intercept divided by kind of the slope, if you will. So it's the opposite of this divided by this every time. Even this one. The opposite of -2 is 2. There's nothing in front of the v, so it's a 1. 2 divided by 1 is 2. So that's how I'm getting those if you want to take note of that. It can save you some time. It just saves you those two-step equations. It saves you time solving those. And it really just comes from repetition, right? I got that from, I do the same thing every time. I do the opposite of whatever's added or subtracted, and then I divide by the number in front of the variable. This one doesn't look too good. I need things that multiply to give me -140 and add up to -31. So let's think 140. Is that a multiple of 4? I don't think it is. Oh, it is. And that happens to be the 1. -35 and +4. Those would add up to -31. So 7x minus 35 times 7x minus 4. And that's going to be off by a factor of 7. That common factor of 7 is in the first one. X minus 5. 7x minus 4. And those 7's cancel out. That equals 0. Meaning that x is either equal to 5 or x is equal to 4/7. Okay. Last one here, we've got 36x squared minus 102x minus 18 equals 0. Those have got to all be factors of 6. So we'll go ahead and pull that out. We have 6x squared. I don't remember that one off the top of my head. I should. 17. That's why, because it's an ugly number. Minus 17x minus 3. That's going to make things quite a bit easier because now I need things that multiply to give me -18 and add up to -17. -18 with multiplication, -17 with addition. That's going to be -18 and +1. So I got that 6 out there. And then 6x minus 18, 6x minus 1, and that's off by a factor of 6. Now, some people always ask, well, can I cancel out those 6's now? You can, yeah. It wouldn't hurt to bring this common factor of 6 out either. That's only going to make life easier. So I have 6 times 6, x minus 3. So that's the common factor between 6 and 18. You actually don't even need to pull that out if you don't want to. It's just going to make it easier to work with in the end. But still, all that's being divided by 6. And that's going to cancel out. I don't really like that. That feels like it's canceling both of those. Just that one. Still feel like I kind of missed it. But so we get 6 times x minus 3 times 6x minus 1 is equal to 0. So that either means that 6 is equal to 0. Not going to happen. x minus 3 is equal to 0 happens when x is equal to 3, and 6x minus 1 is equal to 0 if x is 1/6. Okay, so that was factoring by solving. Sorry, flip that around, solving by factoring. If you have any questions on that, be sure to write them over there on the left side. We will revisit this again. Otherwise, I hope you have a great day, and we will see you in class.